there are more numbers to keep track of, so sometimes you do want to write them down to decide maybe, because there are more to keep track of. When you fill this spot right here, hopefully everybody's got this one filled. When you fill this spot right here, you should have multiplied these numbers times these numbers. First row times first column. So instead of just first times first times first would give us -1. Second times second would give us -4. Now we have third times third, which gives us 0. When I add all those up, I get -5 in that first spot. Then, I don't know how you moved, I'd always go that way, so then I'm going to do the first row and the second column. So first times first, second times second, third times third, that adds up to 1. First row, third column, 1 times 1, 4 times 4, -1 times 2, what is that, 15? And then we go to the second row and do the same thing. What numbers did you get across the bottom? Did you get that far? 5.
17, 21.
All right, anybody have a question or think one of those might be wrong? We're okay with multiplication. So remember the rule. You can't always multiply everything. In this case, we can because these two match. That's the key. Right? Okay. Now, there are a couple of things associated with square matrices that we need to be aware of. One of them is called the determinant. Now, do not get the word determinant confused with the word discriminant. The discriminant is b squared minus 4ac. And that is associated with a quadratic equation. It doesn't have anything to do with matrices. We are going to talk about the determinant.
It's the inside of the square root.
The determinant is a number, just a number, that is associated with every square matrix. The matrix has to be square. So let me give you an example. Now there are lots of uses of determinants. One of them you're already comfortable with, or at least you've already been exposed to, and that is the vector cross product. The vector cross product uses determinants. But there are a couple of really cool things I'm going to show you about using the determinant. First of all, you got to know how to find it. The matrix must be square. So here is the smallest possible square matrix, 2 by 2. The determinant of P would be denoted like this. Those vertical bars tell me that it's a determinant, which is going to be a number. And that corresponds exactly with vectors, because what did this mean in vector land when I used those bars? What did that mean? Magnitude, which is a number. It's just a number. So this is going to equal a number, like 6 or something. So what is that number that it's going to be? Well, we simply take these two numbers and multiply them. We take these two numbers and we multiply them. And then we subtract those two. So that's going to be how we find the determinant. So this determinant is -13. How did I get -13? I multiplied, and notice where I started. It matters. I started with the main diagonal. It's called the main diagonal right here. If I were writing this set of numbers down, I would start with 1. Start there. That minus that, -13. All right, so let's try this one. What's the value of that determinant?
30.
30.
Oh.
Watch your arithmetic. It's 30 minus 0. That would be 30. Alright, one more.
Alright. So much
What's
potential
that
wasted.
one?
35 minus 4, negative 31. Negative 31. Negative 31.
Negative 31. Kids, the arithmetic is simple. It's this minus this. So if you cannot do it in your head, and apparently some of you cannot, then write it down. Negative 35 minus negative 4. And the answer is negative 31. Okay? Now, what did I tell you about determinants? They're associated with square matrices. So we just did 2 by 2s. Now we're going to look at a 3 by 3. How do we find the determinant of a 3 by 3? Well, obviously, I got more numbers here to deal with, right? So you've probably done this before. Do you remember taking these first 2 columns and rewriting them out here? All right, this is how we do it. So here's the problem. Here's the problem right here between my arms is the problem. That's my determinant. It is a 3 by 3. Brayden? In order to evaluate that determinant, I recopy column 1 and column 2. And I do that carefully so that I don't drop a negative or something along the way. All right? Now remember in a 2 by 2, you did this multiplication first, right?
Yep.
We're going to do the same thing, but we got to do 3 of them. We got to multiply this diagonal, and this diagonal. All right? So here we go. This diagonal would give me 0. This diagonal gives me 12. That diagonal gives me 3. Now add them up. So the total diagonal is 15.
We gotta go the other way now, right?
Now we're going to go the other way.
2.
So that one gives me 0. That one gives me negative 1. And that one gives me negative 10. So that total one is negative 11. Now, I did this diagonal, and I did this diagonal, and what did I do with those 2 numbers? No, I subtracted them. So now I'm going to take these 2 numbers, and I'm going to subtract them, which means the value of the determinant is 26. 15 minus negative 11. That is not hard. That is easy. Let's try another one. All right, here we go. This is a 3 by 3. You are evaluating a 3 by 3 determinant. So here we go. We copy the first 2 columns. Everybody good? Here we go. Multiply 0. Multiply 0. Multiply 36. Add them up. Total them up. Now we go the other direction. So 0, 3, and 0. It is always this minus this, right? So the answer is going to be now what about a 4x4, Chuck said. 4x4s we used to do in the old days, but we don't have time to do them anymore. So next time we're together, we'll get our calculators out. We'll talk about how to do those on our calculator. Now it's time to go, I think. And you're going to period E. I know, it's not as fun as this way.
No. Yeah.
Yeah.
Should we have every class today?